So now that we've talked about the types of questions that might get us some data, whether it's statistical or non-statistical, numerical or categorical, we're going to start to figure out how we can represent this data visually and with words. And so one of the words that's come up in our discussion is the word distribution. So let's just make sure we've defined that. So for a data set, in other words, for a set of numbers or responses that we have gotten, how many of each value or each category are in the set? So we want to kind of see how many of this type of number are there, how many of this type of number, how many of that type of number. It would make a little bit more sense as we look at an actual situation here. So one of the ways we can take a look at the distribution of the data is to make something called a histogram. And we have looked at a little bit at histograms in our preview. So a histogram can represent the distribution of numerical data. So it's got to be numerical, not categorical. And so here we have a bunch of numbers. So the data represents the number of days it takes for different tomato plants to produce tomatoes. Use the information to complete the frequency table. So first off, when we were going through and doing this with a dot plot, we would make an axis, and in this case we'd have something like days for tomatoes, and maybe we'd have 47, 48, 49, 50, 51, 52, 53, etc. until maybe we got up to, I don't know, 65, 66. All right, you can see where this is going. So if we were making a dot plot, you'd have 147 in our data. We have 152. We've got 153, et cetera, et cetera. We have like 465s. All right, so we have the data being shown in a dot plot, a visual representation for each number. And what we want to try to do is, if we have a lot of data, that starts to get a little bit tedious, so that we're making just a very long x-axis here. We could increase our scale a little bit, which is kind of what we're going to get to here. But we're going to translate this into a different type of graph called a histogram. And a histogram really, what we want to do is tally up the frequency of the data within a particular range of numbers. So for example, we're looking at days to produce fruit. Instead of just thinking of, okay, there's 147, there's no 48s, there's no 49s, we're going to be thinking of all the numbers between 40 and 50 that are in our data. Now, technically, it's from 40 to 49. 50 is actually going to be counted on the next one. So let's just look up here. Notice we just have one data value. I'm just going to tally them here. One data value between 40 and 49. Now let's take how many are between 50 and 59. So if we look up here, there are, let's see, 1, 2, 3, 4 between 50 and 59. Remember, 60 gets counted on the next one. So 1, 2, 3, 4. I'm just going to tally them for now. How many are between 60 and 69? So 1, 2, 3, 4, 5, 6, 7, 8, 9. Looks like. So this whole group here, 9 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 of them. I'm just going to keep track over on the side here. So 1, 4, 9. How many are between 70 and 79 days? So 70, so we got 2, 3, 4, 5, 6, 7, 8, 9 again. So this whole group right here, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 of those. How many between 80 and 89? See, we got 1, 2, 3, 4, 5, 6, I think there, right? 1, 2, 3, 4, 5, 6. So there's 6 of those. And then how many between 90 and 99? Just the 1. Okay, so this is where we start to kind of combine our data and create a different type of graph that puts together the number or frequency within a particular interval. So notice on the x-axis here, this kind of like the x-axis, is days to produce fruit. And the y-axis of a histogram is always going to be the frequency. In other words, the amount of values that are within that set. So if we were going to do, say, a dot plot, we would see that there is one single number. Well, first off, there's nothing between 30 and 40. And actually, let's put little marks here because that's going to help us organize. So we have nice equal intervals of 10 on our x-axis here. Notice that there is one data value between 40 and 49. And then there are 4 data values, 1, 2, 3, 4, between 50 and 59. 50 and 60, but notice the 60 is counted on the next one, so that's why I keep saying that we're ending with the 9. Okay, and then there are 9 between 60 and 69. So 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, and we want to make sure we're trying to keep the same height over on the y-axis. Looks like it might be a little bit off. Okay, so this is what a dot plot starts to do. But what we're going to do is we're going to now make it into a histogram. So the histogram basically just makes a bar called a bin of the histogram that tallies up how many numbers are there between 40 and 49. Well, there was just 1, so we just go up to 1 over here on our y-axis. How many were between 50 and 59? So there were 4 between 50 and 59, and so we actually go up. The bin goes up to 60, but technically 60 is counted on the next one. So think of it as like 50 to 59.999. All right, how many tomato plants were there where the days were between 60 and 69? There were 9 of them. Notice there's no gaps between bins on a histogram typically. So we just go from one to the next, and knowing that once we hit 70, that 70 is going to be counted on the next one. So there were 9. How many between 70 and 79? There were 9 again. So I'm not going to do the dots all the way up there. I'm just going to start noticing that I can just put the bin all the way up to the 9 on the frequency side, my y-axis. There were 6 between 80 and 89. So I'm just going to kind of look over on the side here, try to make it correspond with the height of 6, the frequency of 6. And then there was one between 90 and 99, so back to 1. All right, so again, the height of our histogram bin or bar tells us how many data values there are, the frequency of the data values within that range. So each data value doesn't get its own little bar. It's grouped together, in this case, in groups of 10. So notice in that histogram that we just created that we had intervals that were a width of 10. Now, we don't always have to use a width of 10. In fact, there is going to be some judgment calls on what bin width, what interval width would be the most helpful for our situation. What if we had changed it so that we had a bin width of 5 instead of 10? Okay, so if we were using 5, let's go back here. And so now we have to keep track a little bit more carefully. So I'm going to use a different color here. So our first one that we have, it would be a good offset here. Let's use blue. So the bin width, instead of being between 40 and 50, our first number 47, falls between 45 and 50. So notice there's 1 here between 45 and 49. Okay, so now we're going to do groups of 5. So how many between 50 and 54? Okay, so there's just 2 between 50 and 54. How many between 55 and 59? Once again, there's 2. How many between 60 and 64? There are 4 between 60 and 64. How many between 65 and 69? Looks like there are 5. How many between 70 and 74? It's like we have 3. How many between 75 and 79? Okay, there's a bunch of these. 1, 2, 3, 4, 5, 6. How many between 80 and 84? Just those 3. How many between 85 and 89? 3, and then 1 more. Okay, so now we're going to go back to our histogram and notice, all right, how many are between 45 and 50? There was just 1. And actually, let's put our little marks here so we can try to stay organized right above each one of these. Okay, so there was just 1 between 45 and 49. Remember, our bin goes all the way up to 50, but we count 50 on the next one. There were 2 between 50 and 54, so my bin, again, goes all the way up to that 55, but that counts, there were 2 numbers between 50 and 54. There were 2 between 55 and 59. I think there were 4 between 60 and 64. There were 5 between 65 and 69. There were 3 between 70 and 74. I think there were 6 between 75 and 79. There were 3, once again, between 80 and 84. There were 3 between 85 and 89. And there was just the 1 between 90 and 94. All right, so that's what our histogram looks like now. Compared to the original one up here, I can try to get them both on the same screen. Same data set, just different interval values. Compare those two and notice that there is a little bit of a difference in how it looks. So how does the histogram differ from one another? Notice the blue, this one gives more detail. All right, we see a lot more bins, a lot more bars, so there's more detail. Notice we notice a drop, a less frequent bin between this one right here, 70 and 75, and 70 and 74, where that didn't really show up on the red one where we were going by a step size of 10 because it kind of lumped all those together. But we noticed we did have a bit of a drop from 70 to 75 where the bins around it were a higher frequency. This bin also appears more spread out. Oops. I was thinking there appears more spread out. Whereas the first one seems like things were a little bit more lumped together, but it's just a matter of perspective with the scale. This one appears more spread out because it has more bins. It's got more bars that make it kind of look like that. So there are some differences here. So as we wrap this up today, I want you to be thinking about these questions. Sometimes it takes some playing around, messing with the different interval lengths to figure out which one gives us the best overall sense of the shape of the distribution. And again, the shape is kind of like what the overall picture is, what it looks like overall. So what might be a problem with using interval lengths that are too large? Think about that one for a second if you want to pause the video. So if we have intervals that are too large, it lumps all the data together. And there's more than one answer to this. I'm just going to give you my perspective on a couple of these things. It lumps all data together. So less detail. You can imagine if we decided to use a bin width of 100 here, we would have one single bar with a frequency of however many plants there are here. Okay, so that would lose all of the detail if we used a step size or a bin width of 100 or even 50 would, I think, lump everything together if it was, at least if it was 50 between 45 and the 95. But what might be a problem with the interval lengths that are too small? Well, just on the opposite side is you have too much detail. And would be probably hard to read. There'd just be too much information. So what sort of considerations might go into choosing the length of the interval? Again, if you want to pause for a second, just think about that for a sec. But how much space do we have to make? So one thing is just maybe a practical thing. How much space do we have? To make the graph, how much space do we actually have on our page? How many data values are there? So if we had like 200 plants that we were just studying here to see what their overall days to produce fruit was, if we made our bin width too small, it would take us forever to make all of the bins for 200 plants. But if we lumped a few together, then it kind of consolidates. It kind of lumps some things together, and so it makes it a little bit easier to make. And so I want you to be thinking about also how much detail would be helpful. We want enough detail so that we can sort of see the overall shape and notice some patterns, but we don't want too much detail where we're just overwhelmed by it. So I think that wraps up our lesson here on histograms.